Hello, this is section 1.1, Functions and Function Notation. Determining whether a relation represents a function. A relation of a set ordered pairs. The set of the first components of each ordered pair is called the domain, and the set of the second components of each ordered pair is called a range. In an ordered pair, x, y, x is the domain and y is the range. Now, a function, let me tell you the relationship between a function with an example. So in a function, it represents a special representation between your x's and your y's. So let's do this by example. So let's say this first circle represents your x's and the second circle represents your y's. Let x be people and let the y represent birthdays. If you think of birthdays and people for your relationship between x's and y's for a function, then it always helps out. So let's say we have a person A, and they have a birthday, let's say the 1st of January. And then person B has a birthday, say the 2nd of January, right? And let's say a person C happens to have the same birthday as person B. That's possible, right? Um, two people can have the same birthday. That's totally possible. It's okay. All right. So far, if we write this as points, we have A comma 1, B comma 2, and C comma 2. But let's say person A is funny and says, oh, wait, I also have a birthday on the 2nd. Does that make sense? Can one person have multiple birthdays? Can one person have more than one birthday? No, that's not possible, right? So the possibility of having A comma 1, that's not true. All right, so this is the relationship between x's and y's for a function. Notice that our y's can repeat, but your x's don't. So x can't repeat. That's a function. This is a relationship for a function. Definition: functions. A function is the relation in which each possible input value leads to exactly one output value. We say the output is a function of the input. The input values make up a domain, and the output values make up a range. Using function notation. The notation y equals f of x defines a function named f. This is read as y is a function of x. The letter x represents the input value, or independent variable, and the letter y, or f of x, represents the output value, or dependent variable. All right, so this is how we evaluate a function. Let's take a look at the next example. So we're being asked to evaluate f of x equals x squared plus 3x minus 4. So we're given a function. This is our function f. And now each part in our following questions are asking us to evaluate. So let's take a look at the first one, A, where it wants f of 2. So this means that for every x, we're going to plug in a 2. All right, to do so, we're really taking a look at this function, and for every x, we're going to plug in a 2. So we have 2 squared plus 3 times 2 minus 4. Notice I use parentheses. Always use parentheses when you're substituting into a function. All right, so we have 2 squared, which gives us 4, plus 3 times 2 is 6, minus 4. We simplify, this gives us 6. So we have f of 2 is equal to 6. All right, let's take a look at the next one. We want to plug in or evaluate f of a. So this means we want to plug in an a for every x. Again, we have an x there and there. So f of a would be a squared plus 3 times a minus 4. And then we simplify. A squared is just a squared. 3 times a is just 3a, and then minus 4. So we have f of a is equal to a squared plus 3a minus 4. And that is our answer. All right, let's take a look at C. F of a plus b. So this means for every x, I want to plug in a plus b. Now remember, we have an x here and here. So we have a plus h squared plus 3 times a plus h minus 4. All right, just to emphasize, we know a plus h squared means a plus h times a plus h. From here, you can go on to FOILing to expand, and you should get a squared plus 2ah plus h squared. Now we distribute the 3, so we have 3a plus 3h minus 4. We combine like terms, there isn't anything else to combine, so our final answer is f of a plus h is equal to a squared plus 2ah plus h squared plus 3a plus 3h minus 4. All right, I'm all out of space for D. We can go ahead and give this a try. You have part of it done. F of a plus h is what we have here. F of a minus f of a is what we have here, all divided by h. And this should look familiar. This is actually called the difference quotient. And you should have seen this in your college algebra class. Let's go on to the next example. Express the relationship 2n plus 6p minus 12 as a function of p equals f of n. All right, so what this is saying is we want to we want to solve for p, isolate p, and make sure we write it in terms of n. So let's go ahead and solve for p. Let's get p by itself. All right, to do so, let's go ahead and move the 2. So we have minus 2n. We do to one side, we do to the other, minus 2n. And we're left with 6p is equal to 12 minus 2n. All right, to get p by itself, let's divide by 6 on both sides. 6 divided by 6 is gone, and we're left with p is equal to 12 minus 2n over 6. All right, the 6 both divides to 12 and the negative 2. So we have p is equal to 12 divided by 6 is 2, minus, that reduces to 1/3, so 1/3 n. Lastly, we want it in terms of f of n, so f of n is equal to 2 minus 1/3 n. And that is our answer. Next example, does the equation x squared plus y squared represent a function with x as an input and y as an output? If so, express the relationship as a function of y equals f of x. So to begin, no, it doesn't represent a function, mainly because we don't have that special relationship between x's and y's. We'll talk about it sooner, relatively soon. We'll talk about it relatively soon, where we talk about not the horizontal line test, but the vertical line test. But for now, let's approach it the way we did in the previous section. Sorry about that. So let's go ahead and solve for y. If we solve for y, we need to get y by itself, so minus x squared minus x squared. And we have y squared is equal to 1 minus x squared. All right, I want to get y by itself, so let's apply the square root. And don't forget the square root property where we have to write plus or minus. All right, so we're left with y is equal to plus or minus the square root of 1 minus x squared. So do you see how we have that plus or minus? It does not allow us to have a direct function for f. We have two. And as we learn in the future, we'll learn how to deal with this with a piecewise function, or we can make restrictions in our domain. All right, so first of all, this one is not a function. It doesn't have that special relationship between x's and y's. Example, given the graph, we want to find f of 2, and b, solve for f of x equals 4. All right, f of 2. We want to find out what is our answer when we plug in a 2. Well, if we find 2 and we find our answer in our graph, we get 1. We have the point 2 comma 1. So this means that f of 2 is equal to 1. Now b is asking pretty much the same thing but backwards. So it's telling us what our y is. Now we want to find out what is our x. The other one told us what x was, and we want to find that y, that output. So when is our answer 4? When does our line meet a 4? We see that it meets it here and here. To be precise, that's the point -1 comma 4 and 3 comma 4. So we would say it's something like f of -1 equals 4 and f of 3 equals 4. Those are our answers for A and for B. One-to-one function. A one-to-one function is a function in which each output value corresponds to exactly one input value. All right, so this not only does it need to be a function, this is a one-to-one function, which is a special type of function. Now, for a one-to-one function, there's no x's or y's repeating at all in your domain and your range. There's only one copy of x or one copy of y. All right, we have the vertical line test. The vertical line test can be used to determine whether a graph represents a function. If we can draw any vertical line that intersects the graph at more than once, then the graph does not define a function, because a function has only one output value for each input value. So to emphasize this, if we draw a vertical line and it crosses twice or multiple than once, it's not a function. It can only cross it once. So let's take a look at these pictures. This first one, we see it only crosses once. So therefore, this one is a function. For the second one, you see we have a problem. It crosses more than once. So therefore, it's not a function. And for the third one, same idea. It crosses more than once, so therefore it's not a function. These graphs, you've seen them in the past. I know you've seen them in your college algebra course, but they do not define a function. Now, a horizontal line test, this is to test if a function is 1 to 1. We have determined that a graph defines a function. Once we have determined that a graph defines a function, an easy way to determine if it's a one-to-one function is a horizontal line test. And the same idea applies. It should only cross once. If it crosses more than once, then it's not a then it's not one-to-one. All right, that's it for 1.1. I'll continue with 1.2 in the next video. You have your homework here. It's on page 91 in your OpenStax textbook. Thank you.